that you have your intention and then you have your reality, and they don't match. Yeah. And then how do you deal with it? Do you spawn a new chicken, or do you just kind of let the chicken die?
Welcome to the podcast, Holly.
Yeah, thank you.
Nice to meet you.
Yes.
How's the conference going?
Yeah, really well. It's such an interesting conference. The sort of the mix of speakers is always a bit unexpected, and the mix of topics is unexpected.
Yeah, that's the nice part about a large conference, I think. Get the unexpected mix.
Yes.
It's always a surprise for me.
Yeah.
I've been talking to several people already who like discovered random things that they didn't think they were interested in, and it was great.
Yeah. Although you can get the same thing actually at a single track conference.
Yeah, sure.
I've sometimes found, because then you're sort of all in one room, and so then you don't get the choice, and so instead of choosing the things that you kind of already know about, you end up just sort of being exposed to the things that
it's really nice as well. And you had your presentation yesterday, so
I did.
Got it out of the way.
Yes.
And you were talking about what is it, cool things you can do with Quarkus?
Yeah, so I wanted to show something that you could do with Quarkus that people maybe didn't know about, because I think when you say Quarkus, people think, it starts really fast and it has a small memory footprint, which is true, but it also has this really amazing throughput. And so one consequence of the amazing throughput is that it has quite low energy usage because it's more efficient at runtime. So I wanted to show that, but then I also wanted to show some other things. So because you can compile it to a native binary with GraalVM, it means that for CLIs, it's really good. And so you can start writing, if you combine it with Pico CLI, you can write CLIs really quite quickly that are quite powerful, and all of the stuff of, argument parsing and that kind of thing, it's just all taken care of for you.
That's pretty nice.
Yeah, so a colleague of mine, Marcus Azili, he'd written a really cute demo where he was generating memes. So you would just sort of give it your text and it would make the meme for you. But it was web-based. And I thought, well, do you really want to go to a web page to make a meme? I mean, if you wanted to do that, there's many web pages out there already. Yeah, so I thought we can do this as a CLI. Although that turned out to be, I think, often the way that conferences work is that you write your abstract and propose it. Yeah. And of course, you don't start writing it until you actually get accepted, because you don't want to waste the effort. Yeah. And then you start writing it, and then you realize that your abstract was just wildly overambitious, and you promised things that don't work. So I thought, this demo already exists. I can just use it. And then I realized that if you're doing native compilation, you end up quite close to the operating system by definition. Yeah. And if you're doing graphics, you end up quite close to the operating system. Yep. And the two don't necessarily align. And so it turns out that doing AWT Java graphics on Mac OS isn't really a solved problem.
Now maybe it's even become less solved over time.
Yeah, and I didn't really want to solve it.
No, so, I can see that.
Yeah, I might have solved it if I'd had more time, but of course, this was shortly before the conference.
Yes, so not the right time to dive into it.
No, so for that one, I ended up running in a container, which is of course the magic of containers, is that you can take things that otherwise would have been impossible.
Yeah, that's what they're good for.
Just like pop up the container and then everything works. And so you can still generate your meme on the CLI just like that.
Oh,
so
awesome.
It's pretty cool. So I did that. But then I also, one of the nice things about doing conference talks as well is, I think a bit like we were just talking about, sometimes you end up, for attending, even when you're presenting, often you end up pushing yourself outside your comfort zone. Because you say, why is this? Let me figure it out. And then by the time you figured it out, you write a conference talk or you submit the abstract. And then you realize, wait a minit, how does this work? So one of the things I also did, which I hadn't done at all before, was explore WASM a bit. So WebAssembly.
Oh, fun.
And it turns out that although doing native AWT graphics is pretty hard on Mac OS, if you go to the WASM route, it's actually trivially easy because other people have done all the work, which seems ridiculous.
Yeah,
right?
yeah, it does.
So, writing this Java code, just couldn't get it to work on Mac OS. But if instead I had Rust code, which then got compiled to WASM, so the pipeline is Rust to WebAssembly, and then there's a WASM runtime called Chicory, which takes your WASM code and converts it into bytecode. And then you take your bytecode, and of course, once you've got bytecode, you can do anything that you could do on the JVM. So then you take your bytecode, you run it, and then you can compile that to a native executable. And so then you can have that instantaneous graphics processing.
Wow.
And it's actually fast as well. That's the interesting thing about it. So there's two routes that you can do. One is everything is kind of dynamic.
Yeah.
And that's about as fast as you'd expect when you're doing a route from, Rust to WebAssembly to Java.
It's a detour.
But if you compile it to a native binary, it's lightning quick, and it's Rust, but it's Java, and it just sort of makes your head hurt a little bit. But it unlocks a whole bunch of possibilities, because you probably wouldn't ever say, I have a mission to do Rust programming, and so I'm going to do it on the JVM, right? Maybe you just do Rust. But if you have this Java application and there's just one problem that you can't solve, like graphics, then you can pull that in.
Yeah, then it starts to make sense.
Yeah, or another thing that I'm seeing some products using it for is if you want to make user pluggable content, you want to be as flexible as possible. So, so for example, Microx, which is a contract testing framework, and of course they're from the Java world, it's written in Java, but sometimes you're going to want something the users may want something that's not Java. So they can take JavaScript and have, little nodes or modules or whatever they are that are JavaScript. And so you can do the same flow, except for JavaScript is actually even slightly more tortured. So if you want to run JavaScript via WASM on the JVM, what ends up happening is that JavaScript is interpreted. So your JavaScript interpreter is written in C. That gets compiled to WASM. So you have your interpreted JavaScript on your WASM compiled C thing that is then running on the JVM, which again, when you draw your architecture diagram, you just want to cry. But if you just present it to users without showing them the architecture diagram, and you can say, now you can use JavaScript. It's really
that's
good.
something you want. It's a clear benefit.
And another set of colleagues who are they work on a product called Apicurio, or API. I never know how to say it, but it's API management in any case. And they have a similar thing, that there's these legacy languages that they really don't want to write support for in Java, but now they have the ability, because the runtimes for those can compile down to WASM, and so then they can take everything and just have it running inside their product, and it's quite nice for users. So just having those sort of little plug points to the other languages can work really well, which again I had no idea about until I started.
Exactly. No, I was talking to someone yesterday as well who was talking a bit along those lines. Like, do you realize how many things like WASM are starting to unlock these possibilities? And people don't have to pick your language. You can plug something in from another language and it can keep working. And it might be, I think he had some kind of idea of using it to like deal better with legacy code as well, or legacy languages. I don't recall what the situation was, but it was interesting.
One of the things I really want to explore, and I haven't had a chance to explore it yet, is using WASM as a way of managing some of the restrictions on really locked down corporate environments. So with Quarkus, one of the really, really nice features that we have is something called dev services. And so with dev services, the idea is that when you're doing development, you're probably going to have dependencies on a whole bunch of external things. So you're going to have your database. If you're doing observability, you might have like your LGTM stack that you want to see what's going on with. All of that. Or, your Kafka queues or whatever. And so then, it always used to be that, the getting started for your application would be like, to get that started, all you have to do is compile it and then start these 16 services and then configure your application. And it's just like, this is too much work. So with dev services, we use test containers to start up the thing that you depend on. And then we can auto wire it in. So again, you don't have to configure it. All you have to do is not configure it. And we look at the absence of configuration and say, amazing, right, we'll just plug this configuration in for you because we just started it, so we know the endpoint. And it works really nicely. Unless you work for a bank or something like that, where they say, no, you just can't have a container runtime on your laptop because it's a security risk. And for this is one of those things where sometimes I think there's sort of a bit of a disconnect between us on the product development side and our actual users, because we have these, this wonderful freedom of our laptops. And then some of our users are like, I love that feature. If only I could use it.
Exactly. I can't run
sorry about that. But we're starting to see now, there's, I think it's SQLite. someone has taken SQLite and got it running as a WASM binary, which means you can run it in the JVM. And so I'm thinking that a lot of the services that we depend on are similar, where you could compile it down to WASM, and then you could have a dev service that doesn't rely on a container runtime in order to allow you to maybe not as expansive as the full container ecosystem, but for some services, you could still have that zero friction. And again, it's not going to be fast, but when you just want to get up and going, it's worth it. So it's just really cool how many different use cases WASM could be used for. Yeah, it's super exciting. Yeah.
I guess we should insert a bit for the sake of the listeners, in case they don't know what Quarkus is.
Yes.
Maybe I can put that first.
Yes, yes, we can go backwards. Yeah.
So what is Quarkus?
So Quarkus is a Java framework. Mm-hmm. It fits into a similar niche as something like Spring Boot. So it gives you a combination or an assembly of libraries like Hibernate, Rest Easy, like all for all of the things that your application is probably going to want to do that are integrated together and tested together. But the other thing that we do with Quarkus, which we're really proud of, is historically Java has been optimized for dynamism. So the idea was that you could go to your ops team and you could give them your Java application, and then you wouldn't redo your Java application for 6 months, and it would just stay up. And then meanwhile, patches would be hot applied. And of course, this makes no sense in 2025 because we have CI/CD. We have containers. So you don't hopefully people aren't patching their live Java applications anymore. They're just rerunning the CI pipeline and generating a new container or a new binary. But all of that dynamism that was baked into Java, that was really, really clever engineering, it does have a cost, which is that a lot of decisions are deferred until runtime. So things like, what are my dependencies? What's packaged up with me? And of course now, your dependencies aren't going to change at runtime.
No.
And so just by front loading some of these decisions, like the reading of the configuration, the reading of the class path, we can get extraordinary efficiencies. So like I mentioned, we get much faster start time, we get a much lower memory footprint, but we also get much higher throughput, partly because of front loading those decisions to build time. But also because under the covers we're based on Vertex, which is sort of reactive, asynchronous, and so it means we get this really wonderful scalability without exposing that necessarily to the user. Because I think when you say reactive, people go, "Oh, no.
This is a separate
I
thing.
wish to be able to debug my code in peace. I don't want that."
Please.
But because it's transparent, so we have this sort of very transparent moving to build time, which again, if you want to do a native compilation, you're probably going to be aware of it because your build times are longer, but otherwise it's completely transparent to you. Everything just works exactly as it did before. And then we have as well this reactive core, which gives you this speed up. And then as a sort of a consequence of at build time doing this really deep introspection of the application, it means we can do a whole bunch of other things as well. So it means we can improve a lot of the programming models. So the old programming model will still work, but we can make changes like, it's always driven me mad. If you do Java logging, pretty much every logging framework, what you do is you initialize it with a static initializer at the top of your class, and you say, okay, I want to log for this class. And it's like, why do I have to tell the logging framework what class it's in when I'm a person, I'm probably going to get it wrong by copy pasting.
Oh, yes.
It's absolutely. A computer. It should know. So we've now fixed that so that you can have, again, it's optional. If you want to do it the old way, that's all just fine. But you can do sort of a static log method. So you do, capital L log dot whatever. And under the covers, at build time, it will have inserted that static initializer. So there's no performance drag because it happened at build time. And there's no kind of, there's not that kind of debugging weirdness that you get with some dynamic frameworks that do it at runtime, where like what you think the code is doesn't match what the compiler think the code is and stuff. Because it's all at build time, it all just makes sense. But it just means that you can save like a whole bunch of boilerplate.
That's nice.
So we do that. And then we also have live reload. So again, because we do so much at build time, if if you had to rebuild the application every time you made a change, it would be a little bit tedious. And because we do so much at build time, we kind of know what's going on with the application, so we can see what's happening. So you can run what's called dev mode, and it just gives you this live reload. So whenever you make a change, it's updated. It can rerun the tests as well. So it does sort of a reverse code coverage technique where if you're running in dev mode, it instruments the code, and then when you run your tests, instead of seeing what you can see what test is affecting what classes or covering what classes. So then you see what classes affect which tests. So you can run just those tests in a targeted way.
Nice.
And another thing that we have that I sort of take for granted, but when we talk to people, they're like, oh yeah, we really love it, is we've got a dev UI. So we've got a console where each extension can provide a tile, and then you can see things like, what are my endpoints in this application? And you can just look at the tile and see what your endpoints are. And we're starting to expand that as well with AI, of course. So, why did I have this error? Well, let me make a suggestion, which is based on a knowledge of your application rather than just kind of a generic suggestion like you might get from an IDE AI. So it's all quite nice.
Time for a quick but huge thank you to everyone sponsoring us on Coffee. You can become one of these incredible individuals by surfing to ko-fi.com/KODSNACK and signing up to give us either a one-time donation or a monthly support. If you support us monthly on the coffee drinker level for €5, you get a bunch of very nice stickers in your actual mailbox. If you support us on the barista level for €10 or more, you also get a thank you right here. Big thanks to Anders Legell, Josef Landberg, Kalle, Thomas Skäre, Joel Rangsmo, Svante Richter, Michelle, Ingo, and Tobbe Lundberg. Everyone who supports us helps make this podcast possible, and the more of you there are, the better we can make it. We do sometimes have sponsors, but it's actually your support that's enabling us to cover our monthly costs every month. And if you want to support us in other ways, you can of course give the podcast a review in your podcast player, or just tell someone who might like the podcast about an episode. But remember, you are a fantastic person, whether you support us or not. Wow. There's a lot of interesting stuff there. So much stuff that went into one talk. Did it fit?
Well, it didn't, to be honest. So in my talk here, I sort of skipped the whole introduction to Quarkus, and I decided to assume that, Quarkus has been around for 6 years.
People can look it up.
Yeah, people will either know or they can look it up. But even with that, actually, I titled it 5.5 Cool Things to Do with Quarkus, which ends up being 6 demos in 40 minutes, which with the context didn't actually fit. So I fit 5 demos.
Oh, that's impressive.
So I was happy with. But although one of my demos, I only did half a demo, which I was very sad about. I think I'm going to have to go write a blog.
Extra material.
Yeah, a few years ago I did. I just joined the Quarkus team, and so I wanted to dog food everything. So I wanted to learn how to write an extension. But of course, all of the useful extensions had been written. So the extensions provide integration and enrichment with all the libraries like, the Gang JPA or Kafka or whatever. So I decided to write an extension that would allow you to integrate with Minecraft, because this is completely useless. So of course, nobody had written it. So I did that, and I learned how to write an extension and that kind of thing. It was all good fun. And so then this time, because that extension was a couple of years old, I thought, I want to extend it. And because it's 2025, I thought I want to extend it with AI. And Quarkus has a really nice AI integration with LangChain4j. So I thought, let's use LangChain4j to try and construct Minecraft creatures and inject them into Minecraft. And it turns out that's totally possible on the LangChain4j side. It's not quite so possible on the Minecraft side. You kind of have to predefine the levers. So you can make a creature and you can say, okay, here's the variations. But you do have to hard code in those variations. But still, I got it so that I could have it so that the AI would define the name of the creature based on what was going on in the application, which was kind of fun. So like if your application, if the user types in something, then in Minecraft, sort of something that was inspired by what the user typed in will appear in the Minecraft world, and its appearance will be kind of inspired by what was going on in the application. And I've done 2 talks so far based on that demo, where I ran out of time and didn't manage to show.
Oh no!
Because it was actually quite hard work.
You don't say.
Yeah. It was the Quarkus side was easy, but then the Minecraft side and sort of understanding the mechanics of the game engine and that kind of thing, and the client server interaction on the Minecraft side was hard, and I haven't managed to show it. So,
oh no!
Yeah,
I really want to see that.
I know. I think I'm going to have to do a whole talk of just sort of like Quarkus concepts explained through the world of Minecraft or something.
I mean, does that mean that you could do sort of visualize dashboard type things inside Minecraft?
Yeah, I think.
Oh no, we have lots of user delay stuff, creatures running around here or something.
Yeah. So I had a little bit of that. So the sort of the premise for my demo was that the Minecraft was acting as an observability client, because the mechanism for observability is always that you instrument your code and then you send your logs and traces and metrics or whatever out to. I mean, I guess ideally you probably send it out to a store and then you have a client. I sort of merged those two. So if there was an interaction, a chicken would appear in Minecraft with a timestamp, and so then you could see the load on your application by how many chickens were running around. And then if there was an error, the chicken would explode, and so then you could sort of see there's explosions. That's bad.
Stuff going on here.
And then that was sort of fairly. So that was the original demo, but it was kind of limited in the richness of the data, right? Like either there was a chicken or there wasn't a chicken.
There's a timestamp chicken class.
Yeah. So then with the LLM, I had it so that it was sort of providing more of a interpretation of what was going on with the characteristics of the creature changing. So,
I mean, I think visualizing information in new ways is, I mean, it's sort of underrated, or maybe we don't try it enough.
I think so, yeah, because if you look at something like a Grafana dashboard, it's very useful, but it's a lot of levers and that kind of thing, and it does seem like sometimes you could have something that's richer. So I think all of those metrics would be. Well, I was going to say easy to visualize in Minecraft. Easy is probably not the right word. And then I was going to say natural, and natural is probably an even worse word. It would be, it would be fun. That's the right word. It would be possible to have the sort of your Minecraft world shaped by what's going on in the physical world of your application. And then it does allow you to have these sort of novel visualizations and this novel way of understanding the application. And probably, I mean, you could almost go to sort of like a, kind of the original William Gibson dream of cyberspace, almost where sort of what's going on in the real world starts to become reflected in the Minecraft world in a slightly literal and dangerous way, right? So that, if your application is under load, then all of a sudden you're having to...
things look different and act different.
I mean, you could probably do things like, I started to have the idea and then I've just blanked on the word. With reactive systems, you need the pushback on the load, and there is a word for pushing back on the load.
Back pressure?
Yes, thank you. That's the one. Yes, I was so close.
Very, very close.
And you could probably manually implement the back pressure, which is obviously not how you should implement back pressure. But the sort of the load is coming in, and then you have to kill the load to implement the back pressure. Or you can sort of start to do really idiotic, impractical, non-production suitable things like that. But it's a way of kind of understanding the concept, isn't it?
And I'm thinking of sort of adjacent to Simon Wardley's keynote about mapping things, like seeing it from a different perspective gives you new impressions.
Yes, you're right. Yes, that's such a good way of thinking of it, because it's the same information, that you understand the problem differently if you lay it out in a different space. I mean, it's the old Matrix scene. We're looking at the code, and I see different stuff. You can also see it in a different way, so you don't have to translate it. It's really cool. More Minecraft dashboards, please. It's not a Quarkus thing, but Sébastien Blanc used to do a Minecraft demo to explain Kubernetes concepts, and it worked so well, because in Kubernetes, the sort of the way it works is that you have this proliferation of different things, right? So you have your pods, and then you have your nodes, and then you have your cluster. Well, I guess you have probably in a real company, you have zillions of clusters, because the cluster has become the unit of deployment, which wasn't the intention. But that's a different topic. Certainly, you have all of these sort of CRDs that are proliferating, and so then you do end up with a kind of this zoo of types, which can map really nicely to the zoo that you get in Kubernetes. And then you get the sort of the intended behavior and the emergent behavior, which again don't end up matching. So what he had was, I think he had something like the containers were chickens, when he was doing his demo, a fox came along that wasn't part of his demo, that was just part of the Minecraft world, and ate one of his chickens.
Oh, no.
So then that killed the container. But of course, that's exactly how it works in real Kubernetes, right?
Exactly.
It's like something happens, and then your container just dies.
Didn't see that one coming.
And so you could really sort of understand exactly that you have your intention, and then you have your reality, and they don't match. And then how do you deal with it? Do you spawn a new chicken, or do you just kind of let the chicken die?
My visualization dashboard killed the process. Didn't see it. I said, this is awesome. So another great thing that I wanted to talk to you about was I saw you speak in Gothenburg. Was it a month ago now? Maybe?
I think, like 2 weeks.
Time flies.
Yeah.
But you talked about developer joy.
Yes.
And I thought that was such a great topic. And I feel like it's more worth talking about now than many times else, because there's so much hype about artificial or like machine support. And
and there's sort of a couple of aspects of it. One is like what we've just been talking about with things like Minecraft, where it is so absurd. It is really difficult. You can kind of try. You can maybe make a practical argument, but realistically, you're never going to deploy it to production. But it still has some value in terms of explaining concepts and that kind of thing. But then there's another one which is actually, you probably wouldn't be ashamed to talk to your boss about, which is that there's this really strong correlation between joy and productivity. If you think about this in terms of your day, we all want to be productive. And when you go and you spend, an hour on an expense report because the system didn't quite work, and then you spend 2 hours in meetings that have no value to you, you're not enjoying them. And the reason you're not enjoying them is because in your heart of hearts that is not making you able to do what you're actually supposed to be doing. It's preventing you from doing it. So when we find things tedious, that's a red flag that they are value free. And so if we get rid of those tedious things, if we say, no, actually, because I think as well, sometimes we have this sort of slightly Calvinist idea that, we're at work to suffer. And so the more we suffer at work, the better an employee we are. So, if I spend 2 hours on the expense report, then that makes me extra heroic. But, no, that's not the right way of thinking about it. We should be thinking about it as what really makes me happy is adding value. And so if I maximize the value, I'm also maximizing my happiness. And so let me go out and try and get rid of these barriers, and let me get rid of these tedious things that will help me, that will also help my colleagues, and it will help the company. And this is something, when you say it, it's sort of, that sounds correct. But there's tons of research that really backs up this correlation. So going back to the first Dora report, they found the number one predictor of organizational performance was employee satisfaction. And you can say, well, maybe the correlation's the other way around, right? That, the employees are happy because the company's doing well. But, the point is that there is this correlation.
Exactly.
And you can see it. So you can see it in tech. You can see it in really unexpected places as well, like in agriculture. There was research that found that if piglet litters are playing more, that is correlated to them growing faster, which is correlated to them reaching market weight faster. And obviously it doesn't end very well for the piglets.
No.
We won't go there.
It's not the outcome.
But the sort of the beginning of the story is that the happy piglets that are playing more are actually more profitable. And so that's another one where you sort of say, oh, well, actually, I think the correlation's maybe the other way around. And it's not like they're growing because they're playing. It's they're playing because they have enough energy and their basic physical needs are being met. And so then that means that they're healthy and so they have energy to play. But it doesn't really matter. The point is still that, you don't look at those piglets and say, how dare you play, pig? You should be like doing something, more productive.
Go and be productive.
You say, this is awesome. You are a profitable piglet because you are a playing piglet.
Well, I have a memo like that from HR. Maybe you shouldn't have put it out saying piglets.
I had, it sort of then guides us into a little bit the sort of the discussion of metrics, because of course we all know that management love metrics, and every metric lends itself to being gamed.
Yeah.
And at the point at which a metric becomes a target, it ceases to be a useful metric and
Yeah,
that
yeah.
kind of thing. But of course, the organization does want to know
Yeah.
how things are doing.
Yeah.
And so if instead of measuring things like lines of code, we can, for the piglets, we can measure how much they're playing.
Yeah.
But I was on a call. I was working with a team in South Africa, and the line was so poor. And so we were doing, a stand-up around a phone, and I could not hear a thing that anybody was saying, and which was a bit awkward, right? Because I was supposed to be
say the least.
helping this team and keeping an eye on how things were going. And so then my manager asked me, well, how is the team doing? Are they on target? I have no idea.
How should I know?
I didn't hear a thing. But the one thing that I could hear on the call was I could hear that they were laughing. And so I knew that if they were really behind, they would not have been laughing on that stand-up call. They would have been probably yelling at each other and going, Bob, why didn't you do the thing? And now I'm blocked because, you made this mistake.
Yeah.
But instead they were laughing. Yeah. And so it showed that they were working well as a team and that they felt that they had enough leisure to have a laugh on the stand-up call rather than kind of being, okay, we need to go back and write more code because everything's falling apart.
Yeah.
So
that part, having some leisure, having some space, breathe and stuff like that.
And so I'm not really suggesting that the new metric for productivity should be how much people laugh on the stand-up, because that could...
But there are worse metrics.
Saying. Exactly.
I mean, it's definitely a good measure of some parts.
Yeah. You don't want the mandatory fun officer, though, who goes round and...
the MFO.
Exactly. The CFO, Chief Fun Officer, goes round, did you laugh enough on today's stand-up? If not, we will introduce 3 more jokes. Every team is responsible for, 6 jokes. If your joke doesn't get a laugh, then I'm afraid that's, a performance improvement plan for you.
Daily stand-up takes on a new meaning. It's horrible.
And this is why metrics shouldn't become targets.
It's hard to stay away from. I mean, everyone understands why we end up there. How did you come upon the idea for that talk? Where did it come from?
That's a really good question. It's something that I've been talking about for quite a while because I think it's so important, and it's something that when people hear the talk, generally they leave really happy because they're like, exactly. I get it, and this is important, and now...
And it rings true. And
and now I have the framework to have a conversation with my management as well, to be able to go back to my management and say, look, we should be optimizing for this, and I'm not saying we should optimize for this because I'm selfish and want to have fun. It's because I care about the business. And I think it sort of came out of seeing the opposite implemented so often and seeing organizations where, there really was this sort of idea that if we stop our developers from having fun, things will go well. And one of the sort of interesting things about giving that talk as well is that afterwards people will often come up to me and, like I said, sometimes they'll say, thank you, now I have the language. But sometimes they'll tell me their horror stories. So I heard one person told me a story that they had sort of a team culture that people would bring in cake and then they would leave cake in the office kitchen and then they'd send around an email. And HR came to them and said, you must not use company resources like email to tell people about cake. And I just thought, that's so utterly misguided.
It's broken in every way.
Yeah. And there was sort of a similar thing, this was many, many years ago. I don't know if many people will remember, there was a time before ubiquitous internet when to get internet you had to go to an institution. So people wouldn't have internet at home, but their workplaces would have internet. And so then what this team did was they were a distributed team across a couple of sites, and after office hours they would have the equivalent of LAN parties, but using their workplace internet. So they would play like Doom or something, and it was fantastic because this distributed team was sort of working, playing together, which is working together, doing team bonding. It was out of office hours, and the company came back to them and said, you cannot use our internet facilities for this frivolous thing like playing Doom. It was just so short-sighted because this team was coalescing as a team. It was out of office hours. The infrastructure was there.
Yeah, it's just sitting there.
And so why stop that?
Should be encouraged.
Yeah, exactly.
It's also, also happens so easily, I guess.
Yeah.
Someone starts with a good intention somewhere and it just goes a little bit out of hand and it's completely outrageous. And then people are unhappy and then people leave.
Well, exactly. That's the thing. It's sort of there's the productivity impact, and then there's the retention impact, which is another story that I heard. It was a bank, and they were sort of moving towards the cloud, and of course, banks are rather security conscious for very good reasons.
Yep.
And I think, things have relaxed a bit, but certainly in the early days of the cloud, it seemed very much like an area of dragons in terms of security.
Yep.
And so they wanted to start using the cloud, but they were concerned as well. So what they did was they basically put a firewall through the middle of the company. And so either you were on Team Cloud or Team Not Cloud. If you were on Team Cloud, you were your laptop was completely prevented from accessing anything inside the firewall. And things inside the firewall included basically all of the systems that you needed to do your job, and things like the team meetings and, the sort of the team calls from the executive explaining the strategy. And so these poor people who were on Team Cloud, like they had one laptop, they didn't have two laptops, but their laptop wouldn't let them do their job. And because of this firewall that had been put right down the middle of it. Yeah. And I think they had something like 7 people leave in 6 months from that team because people went, well, this is stupid.
Yeah.
And it's get back to that thing of if something is really introducing a lot of friction, it affects every layer. So it affects the productivity, it affects the morale, which affects the productivity, it affects the retention, which affects the productivity. Yeah. And so the cost of that isn't just, the sort of, it takes us 2 minutes a day to do this. It ripples all the way down and it can really multiply.
Yeah. My job feels just frustrating.
Yeah.
It's 2 little things, but if I remove them, everything feels infinitely better.
Yeah, exactly.
Yeah, so there's a lot to it. Has that talk been, is there a video of it somewhere? Because I want to link to it for the show notes when we release this.
Yeah, so I've got a website, hollycummins.com, and on it I have sort of all of my talks listed, and then I've just recently done it so that you can actually see if the talk has a video. So if you sort of look at the listing, some of them have a little camera icon. Of course, I never have enough time. So one of the things that I want to do next as well is for each talk, because some of the talks, of course, I give multiple times, and usually there's a best version. So I want to have it so that if you click on one talk, you can see, okay, well, here's the other versions. This one doesn't have a recording, but here's another version with a recording and that kind of thing. But I haven't done that yet.
This is a staff recommended version.
Yes, exactly. Yeah.
That's good.
Yeah.
I like to include as many links as possible so people can look everything up.
Yeah. There's as well. I think to get the sort of the all of my stuff on the topic of fun, I think if you go to hollycummins.com and then you go to, I think it's topics, and then there's various topics and one of them will be fun. And so I can, we should be able to find that link. That's the direct link to the fun topic.
Perfect. Yeah, this was really great. Super interesting. Anything else you want to throw in at the end?
No, I think
we covered so much ground.
Yes, I've talked very fast and covered quite a lot. So people can watch it on half speed or listen on half speed.
Exactly. And then they can go to hollycummins.com if they want to know more. You can get in touch.
Exactly.
Yeah. Thank you so much.
Yeah, my pleasure. Thank you.
Big thanks for listening to Kodsnack. If you want to support us, leave a review in your podcast player of choice, or just tell someone who might like the podcast about an episode. And don't forget you can come hang out in our Slack channel. A link is in the sidebar right on our website at kodsnack.se. Once again, big thanks for listening. Talk to you later.
Let me put it this way, Mr. Raymer. The 9000 series is the most reliable computer ever made. No 9000 computer has ever made a mistake or distorted information. We are all, by any practical definition of the words, foolproof and incapable of error.